Hi, good morning, everyone. Or at least it's morning in the UK here, maybe completely different time of the day for many of you. And welcome to this first of two modules on getting ready to teach Pearson EdXL International GCSE Chemistry. The second module will be at exactly the same time tomorrow. Okay, and just to reiterate what Claire had said, that if you want to ask me a question, can you just put it into the chat box, please? There are far too many people here to be able to allow me to let you have access to the microphones. So just put anything into the chat box, and I will try to monitor the chat box as often as I can. Okay, so without any further ado, I will now carry on with the presentation. Our aims and objectives of today's session is to understand, first of all, how the qualification is devised, then to review the content of the qualification, then to understand the basic assessment of the qualification, explore how to plan the course for your teaching, and to identify any support that's available from Pearson to help you in planning this particular teaching of this course. So the session agenda is, first of all, to give you a little introduction to Pearson, so there's a little bit of welcome to Pearson to let you know exactly what we're about, and then to have a look at the assessment model for the International GCSE Chemistry, then to have a look at the assessment of the qualification, followed by planning, and then an opportunity to have a look at the support, and an opportunity, obviously, for you to give some feedback through the chat box as and when you feel appropriate. So first of all, welcome to Pearson. We are the world's leading learning company. And as the UK's largest awarding organisation, we feel that we're best placed to provide qualifications that are aligned to the British education system. Our international heritage actually stretches back over 150 years. And today we partner with schools and universities and employers worldwide, offering world-class, globally recognised qualifications to over 3.5 million students a year. We are trusted and recognised qualifications partner to 6,500 schools, colleges and employers globally. And we mark over 10 million exam scripts on behalf of the UK Department for Education each year. And we operate in 70 countries worldwide. Okay, so that's a brief introduction to the company. Now let's have a look at the nitty-gritty and have a look at this particular qualification. First of all, the assessment model, which tells us how we go about assessing the candidates so that we can award them a particular grade. The key features are that there's a choice of two particular qualifications, a linear or a modular route. And I will outline the difference between the two in the next few slides. There's no separate practical exam. The practical skills are actually assessed on the papers themselves. The papers in both linear and modular have similar question styles, and I'll look at the type of question styles again later. The other thing that's of interest is that there is no tiering of papers. So there's no foundation paper and no higher tier paper. Both papers are actually graded from 9 through to 1. If you're happy with the linear approach, there is no pressure to move to the modular route. Linear international GCSEs will continue to be offered and taken widely by students around the world. But the modular there is as an alternative. Just to remind you about the linear route, if you're not familiar with it, assessments for all the units are taken together in one exam series. So there's a straightforward target to hit for the linear route. In the modular route, however, unit assessments can be taken over multiple exam series. So you can actually build up the units to finish up with a qualification at the end of it. The grades are calculated on raw marks only in the linear, but in the modular, they're calculated on raw marks, which are then converted into a uniform mark scale. And it's the uniform mark scale that is used for the grading purposes. In the linear route, the students can resit assessments for all units together in one exam series. So if they want to resit, they'll have to sit all the exam papers again. And there are 2 exam papers in the linear route, so you'd have to sit both. However, in the modular system, the students can resit individual units in any exam series. In the linear route, the grade the students received are calculated at the end of the exam series in which they sat their assessments. Once a student in the modular route, once a student has all their unit results, they can, if they wish to, cash in these results for their particular grade. There's no requirement to do so because they may decide that they want to sit a particular module at a later date and perhaps use an improved mark in that particular module to then cash in. So they don't have to cash in immediately if they don't want to. One particular important point I think that needs to be raised is that the modular route is only offered by Pearson Edexcel at International GCSE. As we speak, there is no other awarding body that is offering the modular route for International GCSE Chemistry, or indeed any of the sciences. Okay, so just to give you a brief introduction of the specification content, it is split into 4 categories: principles of chemistry, inorganic chemistry, physical chemistry, and organic chemistry. It's a pretty standard format for a GCSE specification, and I'll give you just a little while just to have a quick run through that. In the principles of chemistry, you'll see the usual things: states of matter, elements, compounds, mixtures, atomic structure, periodic table, chemical formula, equations and calculations, ionic bonding, covalent bonding, metallic bonding, and electrolysis. And the inorganic chemistry, exactly what you'd expect: group 1, group 7, gases in the atmosphere, the reactivity series of metals, extraction and uses of metals, acids, alkalis, titrations, acids and bases and salt preparations, and chemical tests for gases and ions in solution, or indeed in solids as well, because there's flame tests is included. The physical chemistry is restricted to energetics, rates of reaction, and reversible reactions, equilibria. And the organic chemistry has got basic introduction to things like homologous series and general formulae, etc. Crude oil, alkanes, alkenes, alcohols, carboxylic acids, esters, and some synthetic polymer work. How do we go about assessing that? Well, there are 2 papers, regardless of the route. Paper 1 in the linear route is a 2-hour written examination. The total number of marks for that paper is 110, and that is 61.1% of the total international GCSE. The content that is assessed is all of the content that is not in bold in the specification. So if you look at the specification for the linear, you will see that certain of the specifications points, or statements as we call them, are in bold. Those bold statements, and which also have a C prefix, are not assessed in paper 1. But questions can still be taken from any of the topic areas across the specification, so any of the 4 major topics. Now, The assessment in the modular route is totally different because only certain sections will be assessed from topics 1, 2, and 3. Perhaps the easiest one for you to spot is in physical chemistry. Only energetics will be assessed in the modular route in paper 1. There will be nothing on rates of reaction and reversible reactions and chemical equilibria assessed in paper 1. And you can see in the organic, you've only got introduction, crude oil, alkanes and alkenes. So that might be something that you need to take into consideration if you are going down the modular route and planning your course and how to deliver. In paper 2, for the linear, it's a 1 hour 15-minute exam, which has a total number of marks of 70, which makes up the other 38.9% of the total international GCSE. And the important thing here is that it will assess all of the content, including the content that is in bold and has a C prefix. And the important thing there is that it assesses all of the content. Some students seem to get it into their minds that in paper 2, only the work that is in bold and has a C prefix in the specification will be assessed, and they go around and just revise that. Well, they need to be made aware that everything can be assessed in paper 2. In the modular route, it's a 1 hour 40-minute exam. Total number of marks 90, like it was in paper 1, 50% of the total international GCSE. And you can see, if you look at the physical chemistry this time, you can see that there's no energetics being assessed in paper 2, but there is rates of reaction and reversible reactions in equilibrium. And in the organic chemistry, you've got the alcohols, carboxylic acids, and synthetic polymers being assessed. So there's a slight difference in the way that the two papers will be constructed in the linear and the module. Okay, I can see a couple of questions in the chat, so I'll just pause for a moment to have a look. Okay, right, it's nothing that it looks like I need to be concerned with, so I'll move on. Okay, so I think pretty obviously teaching in a linear way is pretty straightforward. But if you're moving over to the modular, then you may want to consider changing your teaching style. To support that, your planning and teaching the course, we have in fact produced a course planner, an editable scheme of work, and a getting started guide. And these are all available on the relevant qualifications website. So you simply go to Pearson qualifications. If you type that into your search engine, then you will get a search coming up, and you click onto the Pearson qualifications website, click on International GCSEs, click on chemistry, and then you've got a choice of going to the linear or the modular site. And if you click on the modular one, you'll see that there is a course planner, scheme of work, and getting starting guide listed in that particular section. The first teaching for the International GCSE has actually already started in this September. So if you are thinking of moving over to Pearson's and are not teaching it yet, then you may want to consider the modular, in which case you'll probably start teaching it next September 25. The first assessment will be in May/June 2025, and both questions on both papers will be set. So if you are teaching your course as a one-year course and you have to teach everything inside 1 year, and I know that some countries do teach this in 1 year, then you can teach both module 1 and module 2 and have your candidates sit both so that they can actually get a cash-dean grade. Just a little bit about resits for modular international GCSE. students can resit any unit irrespective of whether the qualification is to be cashed in or not. If a student resits a unit more than once, only the better of the two most recent attempts of that unit will be available for aggregation to a qualification grade. This is very important when students are considering whether or not to have a resit. If they happen to have 3 resits and their first mark was their best mark, then that will not count, because the better of the second and third resit will be the one that counts. So that is something to take into consideration. The results of units will be held in Pearson's Edexcel unit bank for as many years as this specification remains available. And once the International GCSE in Chemistry module has been certified, all unit results are deemed to be used up at that particular level. Okay, I can see quite a few come into the chat box again, so I'll just pause for a second. I have absolutely no idea if we can acquire electrical certificates after training, but at the end of the presentation, I will give you details of the Pearson officer who's in charge of this qualification, and you can answer that question. Okay, I don't know how to download the resources. If you put that into the Q&A box, then perhaps Claire can let you know. Okay. Okay, all right, moving on. These results cannot be used again once towards a further award of the same qualification at the same level. Okay, so let's have a look at the assessment of the qualification. Each topic and subtopic contains several specification statements. For example, this is taken from the linear specification. The very first topic that crops up is states of matter, and you can see that there are various specification statements there, like 1.1, understand the 3 states of matter in terms of the arrangement, movement, and energy of particles. One of the most important things for you to do is to look at the specification and make sure that you cover every single one of those specification statements. So this basically is telling you what you need to teach and what the students will be assessed on. Again, there's some things coming to the chat box. Okay, again, it doesn't look as though it concerns me, so I'll move on. If you happen to have a specification in front of you, a linear specification in front of you, or a modular one, I wonder if you can find out where that specification statement is. Don't worry if you haven't, because I will be pointing out where it is. The clue is in the linear specification, it's and in the modular one, it's in topic 2, inorganic chemistry. Don't put any answers into the chat box. There's far too many of you here for us to be able to look at it. Just keep it in your head. So if you've got a specification in front of you, then just have a quick look. I will be talking about the experiments later, okay, in answer to the question on how many experiments are required for this particular qualification, okay? The answer is 2.16. Understand how metals can be arranged in a reactivity series based on their displacement reactions between metals and aqueous solutions of metal salts. When the exam paper writers are writing their questions, they have to write questions on specific statements that the chief examiner has stipulated the paper must be on. Okay, so this particular question, obviously the chief examiner said, I want a question on 2.16 set, and this was the question that this particular examiner came up with. And if I remember correctly, I think this was one that I wrote quite some time ago when I was the principal examiner for this particular paper. If it's the modular system, it is actually specification point 2.2. You've got that one in front of you. Okay, and there's another one. Which particular specification point is this taken? And this obviously is from physical chemistry, and it must be something to do with the reversible reactions in chemical equilibrium. Again, I do recognize this question because it is one that I wrote quite some time ago, probably for the 2019 paper, which is the last papers that I wrote as principal examiner before I retired from examining work. If you've got the specification in front of you, see if you can find. Explain what is meant by dynamic equilibrium, and then some N2O4 and NO2 are put into a sealed tube. Explain why the new equilibrium mixture contains less NO2 than the original. So obviously it's to do with the effects, qualitative effects of changes in conditions. It's in topic 3. While you're just looking at that, I see something coming into the chat. Oh, someone's actually put up an answer. The answers are, for part A, 3.2, know that the characteristics of a dynamic equilibrium are the rate of the forward and reverse reactions occur at the same rate, and the concentrations of reactants in products remain constant. Okay, you notice this is a no statement, therefore it is straightforward recall, and all the students had to do to answer that question was to copy out those two statements. And I always encourage my students to learn the no statements off by heart and not feel they have to put their answers into their own words. We are expecting students to give word for word answers to the no statements. They can quite happily learn those off by heart and regurgitate them in the exam. The second one was 3.22c. Know the effect of change in either temperature or pressure on the equilibrium position of a reversible reaction. Okay, an increase or decrease in pressure shifts the position of equilibrium in the direction that produces the fewer or more moles of gas. Okay, increased, fewer, decreased, more. Note that in the specification, there's absolutely no reference whatsoever to Le Chatelier's principle. That doesn't mean that you are stopped from teaching Le Chatelier's principle if you actually want to, but you have to bear in mind that no credit will ever be given to any answer that contains reference to Le Chatelier's principle. So there's absolutely no need to teach Le Chatelier's principle. Indeed, if I had on another occasion the opportunity of talking to you about using Le Chatelier's principle, I would try to encourage you not to use it at all. In the modular qualification, the specification points are 7.12c and 7.14c, because they're topics that will be in paper 2. Okay, as I said, I was principal examiner for this particular qualification from 2010 right the way through to 2018, and therefore I did build up a big knowledge of the sort of common errors that are seen in answers in this qualification. So I'd like to share a few of them with you. I can't share them all because obviously we don't have enough time, but here are a few of them. Referring to intermolecular forces of attraction when discussing the properties of substances with giant covalent structures or ionic compounds and metals. You'd be amazed at how many people think that giant covalent structures are molecular. And I have some sympathy with them because quite a number of textbooks do describe things like silicon dioxide and indeed diamond and graphite as being macromolecules. where in fact our UPAC, the International Unit Pure and Applied Chemistry Handbook, quite clearly states that macromolecules are polymers. They're made up from a large molecule composed of several small units joined together, i.e. polymers. That is the definition of a macromolecule. So silicon dioxide is incorrectly described as a macromolecule. Since they will come across this either in other textbooks or sometimes on the website, I've got some sympathy with them thinking that it is molecular, when in fact, of course, it is not. Try to avoid using the term macromolecular to describe giant covalent structures. Another common error is stating that covalent bonds are weak and therefore require little energy to break when explaining why simple metal substances have low melting and boiling points. So instead of concentrating on the relatively weak intermolecular forces of attraction, a number of students will focus on the covalent bonds when they're explaining that particular property. Losing marks when writing chemical equations by getting the formulae incorrect. So for example, H instead of H2, MgCl instead of MgCl2, very, very common. NaCl2 instead of NaCl is very common. Number of times I've seen the equation Na plus Cl2 arrow NaCl2 is unbelievable. I've seen it on so many occasions, not only at GCSE, but also A-level. I did a lot of marking for A-level for Pearson's, and I even see that mistake made by students at A-level as well. So doing a lot of work on formulae is very, very useful because it will enable students, hopefully, not to lose those silly marks. Another common error is referring to changes in energy, particularly kinetic energy of the particles, when explaining the effect of surface area of the solid or the concentration of solution on the rate of reaction. Providing contradictory information when explaining the effects of change on a variable position of equilibrium in the reversible reaction. You often get people giving contradictory information, and the thing about contradictory information is that if there is some chemistry that's correct and the other information they put down contradicts this, then they cannot be given credit for the correct chemistry. They will get penalized for putting down information that contradicts what they put down that's correct. So it's very, very common to see contradictory information in that particular topic. So, for example, here we have an equation in which the forward reaction is exothermic. A decrease in temperature will increase the yield in ammonia as the equilibrium shifts in the endothermic direction. Okay. There is contradictory information there. Note that Le Chatelier's principle is not on the specification. Mark schemes never give credit for the idea that an equilibrium wants to resist a change or moves to oppose a change. So you may think from this, what is the point of teaching Le Chatelier's principle? And the answer, quite simply, as far as I'm concerned, but this is a decision that you must make for your students. My answer, quite simply, is no point whatsoever in mentioning Le Chatelier's principle. There are a lot of things come up in the chat box, so I better just pause for a moment and have a look through them and see if there's anything. Okay. Students appearing in June 2025 are supposed to do both P1 and P2. No, not if they're doing modular. You can enter them just for P1 in June 2025 and enter them for paper 2, second module in at a later session. If they are doing linear, yes, they have to sit both paper 1 and paper 2. Okay, let me do. in UK or international? I'm just talking about international, nothing else. Okay. If a student is willing for modular unit-wise assessments, then how many assessments is he got to take yearly? Just one. They only have to take one yearly, but they can take two if it's appropriate. Okay, it's possible that you shared the correct answer for this question on common errors. Okay, I'm sorry, I'm not quite sure. Not quite sure what you mean there. Okay. Is there a list of key words you can share that students need to recall word for word, or all the no statements, the keyword definitions? Yes, the no statements are the recall ones. They're the ones that they can learn word for word. Okay, do the students need to recall all of them though? They could be asked any one of them, any paper, any appropriate paper. So the answer quite simply is yes. What about the spelling and grammar that you're very strict on this? No, we're not very strict on this. We do realise that students do not have English as their first language, and therefore we're not very, very strict. Unless the spelling changes the chemistry. So for example, if the product of a reaction was ethene and they wrote down ethane, then obviously that cannot be marked correct. But if they are writing down effervescence and they can't spell it exactly, but the word is obviously effervescence, then we would ignore that. Okay. Okay, right. Well, that seems to have answered all of those. So let's move on. Okay. All right, here's something for you to think about. And again, please don't put any answers in the chat box. Okay. All right. Here's a question that I set quite some time ago. SiF4 and FiCl4 have simple molecular structures. SiO2 has a giant covalent structure. Part one of the question was, explain why the boiling point of SiCl2 is greater than the boiling point of SiF4, and explain why the boiling point of SiO2 is very much greater than the boiling point of SiCl2. Okay, so what I'd like you to think about, don't write anything down in the chat box, please, but if you want to write it down on a piece of paper you've got, please do so. What are the essential points to include when answering these two questions? So it's just a thought process for you. And one of the reasons why I like to do this is because it's something that I always try to encourage students to do before they answer a question. Think in their heads, what are the essential points before they start writing? That way, hopefully, they don't start writing information in the wrong areas. So I'll leave you to have a think about that just for a little while. Right, well, on the next slide, I've put down what I think are some of the important points to think about and include when you're answering these two questions. And that is, when you're dealing with the simple molecular ones, to realize that they exist as simple molecules, that there are weak forces between the molecules, the forces are easily overcome, so there will be low boiling points. The stronger the intermolecular forces lead to the higher boiling point. So I would expect the students to say that the intermolecular forces between SiCl4 and SiF4 between SiCl4 are greater than the intermolecular forces between SiF4. So obviously you need more energy to overcome those forces, hence the higher boiling point. And when you are considering SiO2 compared to SiCl4, recognize that the giant covalent structure is a giant lattice and it is not molecular. I cannot stress this too strongly. That there are very strong covalent bonds between the atoms and lots of energy are needed to break these bonds, so you've got a very high boiling point. And once again, there are no molecules, so no intermolecular forces. Okay, now there's one other thing. As well as assessing a particular statement from the specification, each question or part question is also linked to a particular assessment objective. Welcome to Pearson Module 2. Tomorrow is another 2-hour presentation in which you can find out a little bit more about the assessment objectives and their importance in writing exam questions. But there are 3 of them. The first one is basic knowledge, so all the no statements that appear in the specification, and simple basic understanding of chemistry, straightforward understanding comes into AO1. AO2 is all about the application of knowledge and understanding and analysis and evaluation of chemistry, and AO3 is all about the experimental skills, analysis and evaluation of data and methods in chemistry. And when the exam paper writers are constructing their papers, they must keep the number of questions targeted at those 3 assessment objectives within those percentages. So 38 to 42% of the marks must be AO1, 38 to 42% must be AO2, and 19 to 21 must be AO3. So they don't have to have exact percentages, they can be within a range. At the end of the day, of course, they've got to add up to 100%, obviously. So you can see that as a maximum, only 42% of the marks will be accessing recall and basic understanding. The vast majority of the marks will probably be assessing some degree of application of knowledge and understanding, or some degree of analysis and evaluation of data. There will be a little bit of recall in AO3 on the main core practicals that are in the specification. There's the relationship between the assessment objectives to the various units. And you can see the breakdown in each particular paper. All of this information is on the various on the website. The top one is linear, the second one is modular. Okay, so let's now have a look at considering planning of this course. There are 2 key documents needed to deliver this particular course: the specification and the SAMs. Now, with regard to the linear specification, the SAMs are no longer of real importance because there are now a lot of past papers. When the linear specification, this new linear specification first came out, of course, there were no past papers. So I and my fellow principal examiner created papers which we called sample assessment materials, which were in the exact same style as the future exam papers were going to be. So that gave you an opportunity to see how the exam papers would be set out and how they would be marked. Now, of course, with the linear, that SAMs becomes a little bit redundant, although they are there on the website and you can use them as mock exams. You can use it as practice exam papers if you want to. Now, however, for the modular, of course, there are no exam papers set yet because they won't be first taken until May, June 2025. And therefore, we have created some SAMs papers, some sample assessment materials, which are the basis for all the future exams. So that's very important. Okay, the specification obviously goes without question. Okay, now the next two slides gives us a lot more detail on each. So first of all, I'll look at the specification, which of course is the main document that you need to teach the course. It outlines the aims of the course and the content you must cover, every single one of those specification statements. And it also gives you all the information you need about assessing your students. So what I've been talking about earlier about the assessment, all of that lot is on the specification, So you can get all the information there again. Okay. And of course, as I've mentioned before, it can be found on the website for either linear or modular, depending on which one you are interested in. The specification statements are identical in both the linear specification and the modular specification, but of course they are numbered differently because of the different makeup of the two papers. However, they're arranged differently in the modular to reflect the content that will be examined on each paper. As I said, the SAMS is short for sample assessment materials. The document is just as important as the specification as regards the teaching the modular, because it's the only examples of the type of questions that will be set next year that you will have available to you. There are examples of question papers in mark schemes and show the question types and how they will be marked, because there are mark schemes associated with the question papers. Okay. And as I said, we base all of our future papers and the assessments on these sample assessment materials. So how do I make sure that I cover the three things that I think that you need are specification, schemes of work, and lesson plans. That would be my starting point if I was planning the particular course and making sure I covered everything. Okay, as I said, I'm going to say it again, all of the statements must be covered during the time available to teach the content, since questions can be set on any specification point. Schemes of work, these should contain what you teach in any given period and the order in which they will be taught. They are usually organised in batches of 1 or more weeks. The next slide shows an example of one that is on the website. A lesson plan, well, I consider a lesson plan to be a detailed description of the course of instruction for a particular lesson. A daily lesson plan is developed to guide class learning. Details will vary on the preference of you, the subject being covered, and of course, very importantly, the needs of the students. There may be requirements dictated by your school regarding the plan. So obviously you will have to fall in line with those if that is the case. The lesson plan for me was always my guide for running a particular lesson, and it included the goal, i.e. what the students are supposed to learn, how the goal will be reached, i.e. the method or procedure that I would go through to try to get them to achieve those goals, and a way of measuring how well the goal was reached, i.e. will that be a test? Will that be questions that you set? Will that be a worksheet? Will you be assessing that through homework, etc.? There's an example of a scheme of work for the linear, okay? And you can see that it's a lot of information is in there. So please feel free, if you are planning on teaching the linear or already started teaching the linear scheme, have a look at the scheme of work and see if it's of any use to you. You may go through there and you can pick and choose from whatever you like and include it in your scheme of work. You don't have to follow this scheme of work. You can adapt it to suit yourself, but you can see that there are some exemplar activities, some exemplar resources, RSC stands for Royal Society of Chemistry. I would encourage you very much to become a member of the Royal Society of Chemistry, because by doing so, you can access an incredible range of resources. As you may have seen from the first slide I put up, I am indeed a member. I'm a fellow of the Royal Society of Chemistry, and I make use of their resources when I'm actually producing my presentations for these training events. I find it incredibly useful. And if I was teaching, I retired 12 years ago now, 13 years ago, good grief. If I was teaching, I would certainly make sure that I was a member to access those particular resources. So do consider becoming a member. It's very useful. There's an example of the scheme of work for modular. Very similar. It's in a slightly different format, but there are still lots of things about including the statements that need to be covered, which particular part of the topics they're coming from, activities you can do, demonstrations that you can do, class practicals, resources. Okay, so please again have a look at that. Okay, just while I leave that up, I can see that there's quite a lot of questions come up in the chat, and I'll go back and have a look. Right. For the content, I've noticed some ideas not discussed in the textbook and mentioned in the hub, such as teaching curve, for example. Yeah, okay, yeah. Not sure exactly. I've come across some observation about activity text, both content and Excel specification in past papers. I'm not quite sure. Do you expect a textbook to cover absolutely everything? Yeah, I didn't write the textbook, so I'm not sure. Slide is not visible clearly. What is written on the slide? I'm not so sure. That was a little while ago, so I'm not sure which is. Okay. Are the students still supposed to learn all the topics before they take Modular Unit 1 and Modular 2 exam? No, they're expected to learn everything from Modular 1 before they take Module 1, and they're expected to learn everything from Module 2 before they take Unit 2. So they don't have to learn everything for Unit 2 before they sit Modular Unit 1. They may not be able to take Unit 1 and Unit 2 separately, since some topics are closely related. Also, is there a new textbook designed for modular series? No, there isn't. But you will see that in this scheme of work that's up at the moment, you can see in the 1, 2, 3, 4th column from the left, there is a link to where that topic is covered in the existing student book. So there's no separate student book, but there are links in the scheme of work to the pages that cover that particular topic. So that will enable you to hopefully to be able to use the textbook when you're teaching your modular system. I hope that helps. Okay. Right, now, what is about to follow is not anything to do with Pearson recommended policy. This is simply my own ideas on the possible components of a lesson plan. It's the sort of thing that I used when I was teaching. And I'm just going to share it with you so you can make a decision as to whether or not you think that what I am putting down here is worthwhile including or not. At the end of the day, I must stress that I'm not here to tell you how to go about teaching your pupils. There are two reasons. One, I think that would be very arrogant of me to sit here and tell you how to go about teaching your students. And secondly, most importantly, I don't know your students and I don't know what their strengths and weaknesses are. You do. And therefore, you must construct your teaching methods accordingly. But there are some basic things that I think ought to be included in the lesson plan. And I want to share them with you for you to think whether or not you think they ought to be. Okay. There also always ought to be a title to the lesson. There should be the time required to complete the lesson. There should be a list of required materials, and those required materials could be some worksheets that you're going to hand out to them. They could be hard copies of questions that you're going to hand out that you want them to answer. If it's a practical, it would contain a list of all the equipment that is needed, which you can then hand over to your laboratory technician, if you're lucky to have one, so that they can get out the material, the equipment and the chemicals in advance, etc. Okay. A list of objectives, i.e. what the student is expected to know by the end of the lesson. If you haven't got a clear idea of what you expect them to know, then I always said to myself, if I haven't got a clear idea, Cliff, of what you want them to learn, how am I going to go about teaching them? I need to know what they're going to learn. So I need to have a list of that in front of me, so I know what it is that I'm trying to achieve. The lead into the lesson that focuses the students on the lesson's skills or concepts. This could include showing pictures or models or asking leading questions, or it could include reviewing previous lessons. We all know that chemistry is like building a house. You have to put down foundations first, and then you gradually add the layers bit by bit. And very often, by the time you come to the third or fourth story, some of the information that they need to be able to understand what you're doing in the third and fourth story are actually contained sometimes in the foundation, sometimes in the first story. And so therefore you sometimes have to go back to that to review that in order to make sure that we're all starting from the same page. I must admit that when I first started teaching, I didn't fully appreciate this, and this is why some of my students did get in. I found were not doing as well and achieving what I thought they were going to achieve, because I hadn't made sure that they understood what they needed to understand in order to progress. Okay, an instructional component, i.e. how you're going to go about teaching this, that describes the sequence of events that make up the lesson. This includes your instructional output where appropriate, guided practice by the students to consolidate skills and ideas. So is that guided practice in the form of worksheets that you hand out? Is it in the form of questions that you are going to ask them to consolidate these new skills, to make sure they understand, etc.? And independent practice that allows the students to extend their skills or knowledge on their own. There may not be time in the lesson for that independent practice, but of course that could be provided for homework. Okay, there's quite a number of questions cropped up, so I'll just pause there for a second and go and have a look. Okay, you suggest about exam series, either linear or modular, which one is beneficial to students to get most points and which method is preferred? That depends very much on the students. I can't answer that question. Some students prefer linear, some will prefer modular. And I think it's all about your students and what you think they prefer. About the experiments necessary that they make a report of all of them. Is it mandatory? No, it's not mandatory, but obviously they need to be guided into good practice with regard to writing up their practicals, because they will be assessed on that in their practical skills in the papers. So it's not mandatory, but it's good practice. Okay, is there any? If I have videos of all Edexcel experiments, kindly share them. I don't have videos, but I would go into the Royal Society of Chemistry website, where there are quite a number of videos, but there are also some on YouTube. But be very careful about YouTube, because there are some awful experiments demonstrating very bad practice. So make sure. Can you please show requirement experiments that could be included in external examination? They're all listed in the specification. Every single practical that can be tested is listed in the specification. So they're all there, okay? Okay, I think I've answered all of those questions. About the experiments, is it necessary to make a report? A-level is mandatory. It's only mandatory in UK GCE. It's not mandatory in international. They don't have to make reports. Okay. But obviously they are encouraged to do so. They are tested on some of their coursework in GCSE A-level UK, not international. Okay, one new message. Hang on a second. Can I get a scheme of work for linear assessment? Yes, it's on the website. You go into Pearson qualifications, click on International GCSE, click on C for chemistry, and then click on linear. Okay, and then you'll get a scheme of work for linear from that. Okay, right, let's move on. Possible components of a lesson plan. A summary. So have in mind a summary where you wrap up the discussion and answers any further questions that the students may well have. If you're doing a practical, you need, of course, to have a risk assessment where the lessons, risks, and the steps taken to minimise them are actually documented. This is mainly to cover yourself, mainly to make sure that students are operating safely, but it's also to cover yourself. Because if a student doesn't follow your instructions about how to go about minimizing the risks and they then injure themselves, at least you've got documented evidence that you had told them exactly what to do. And then an analysis component where the teacher uses this to reflect the lesson itself, such as what worked and what needs improving. If you find at the end of it, when you carry out your assessment of the students and how well they've understood something, they're not understanding it as well as you would like, then obviously you need to reflect yourself along that particular lesson, or it may be a complete topic, a series of lessons. Why hasn't it worked as well as you was hoping it would? And is there any way in which you could perhaps adapt your teaching to improve the outcome as far as the students are concerned? And this is where, of course, you may want to talk to some of your colleagues within the department if you are not sure about how to go about adapting your teaching to improve. Okay, right, now then, coming to the practicals. There have been a few questions about practicals, so hopefully here I'll be able to answer most of the questions that you've have put in. Before I get on to that, I can see that 3 more questions have come up in the chat box, and I'll go. We thought that an examiner or person can come and ask the lab experiments reports for A-level because it's mandatory, so probably a mistake between UK and international. Yes, I think you are. Yes. Okay. Is there any possibility of P1 syllabus questions which may be asked in P2? Yes, there are some. I can't remember exactly off the top of my head what they are, but they are mentioned in the specification. So read the specification. Is the grading for international students the same as that for UK students? It's the same grading, 9 to 1, but the grade boundaries will be awarded separately. They will be worked out separately from the UK grade boundaries. They will not be the same as the UK boundaries, grade boundaries. Okay, they may finish up the same, okay, but they're awarded completely separately. Okay, right, here we go with regard to the specification. There are 12 core practicals, all listed in the specification. They are listed in italics as specification points. So anything that's in italics is a practical that the students need to know about. So, for example, 1.7c, investigate the solubility of a solid in water at a specific temperature. You'll notice that this is in bold type and has a C prefix. So it's obviously a practical that is linked to, in the linear specification, paper 2, not paper 1. Okay, but some of the practicals are not in bold type, do not have a C specification prefix, and therefore are can be assessed on paper 1. So that's taken from the linear. So they're all in italic. So everything that's in italic is a practical. Okay. There is another one, 2.43c, practical. Prepare a sample of pure dry lead-2 sulfate is another practical. And again, that's one that the students need to be aware of. Okay. So obviously, it's very important to do the practical and to cover all of these practicals that are listed in the specification. In an ideal world, the students need to do every single one of these. Okay, I think someone's got their microphone unmuted. Could you go back and mute it, please? I can hear something coming through my headphones. If you haven't got the chemicals or the equipment to do a particular practical, then as a class practical, but you have got it to do as a demonstration, then the next best thing is to do it as a demonstration. If you haven't got enough equipment or haven't got the right equipment or you can't get hold of the right chemicals for a particular practical, then you can substitute it. You don't have to do, for example, dry lead-2 sulfate. You could choose another insoluble compound. It doesn't have to be lead-2 sulfate because the techniques of preparing an insoluble compound by precipitation reaction and then filtering off the precipitate and washing it with deionized water and then drying it are all the same, regardless of which particular salt you're producing, because the test, what you're going to be assessed on is that particular method, not necessarily the exact same chemical. So you can substitute chemicals, providing the practical is developing the same skills. If you can't do it either, then obviously search for videos on either the Royal Society of Chemistry website or on YouTube. Okay. It's strongly recommended that students complete these core practicals in order to develop skills, because it's the skills that they will be tested upon. Other suggested practicals appear in the specification. They are optional. You may add or substitute your own practicals too. The more practical work they do, the better. The best way to develop experimental skills is to embed practical investigations into teaching or theory. Try to teach them side by side and try to show how the practical is supporting the theory and how the theory is supporting the practicals. It is by far the best way to develop the students' skills in order to enable them to be able to be in the best position to answer the questions that will be set. And if you go and look at these types of questions over the series of past papers, I think you'll see immediately what I'm getting at. The development of knowledge and experimental skills can then happen together, and that leads, in my opinion, to a much more secure acquisition of both knowledge and skills. In the assessment of experimental skills, the students may be tested on their ability to solve problems set in the practical context, apply scientific knowledge and understanding in questions with a practical context, devise and plan investigations using scientific knowledge and understanding when selecting an appropriate technique. So the more opportunity that you give them to devise and plan investigations, the better. And they may be asked to demonstrate or describe appropriate experimental and investigative methods, including safe and skillful practical techniques. So they need to know how to perform experiments safely and skillfully, because they could be tested on that. They may also be tested on their ability to make observations and measurements with appropriate precision and record these methodically and present them in appropriate ways. And to identify independent, dependent, and control variables, and use scientific knowledge and understanding to analyze and interpret data to draw conclusions from experimental activities that are consistent with evidence. And they may be tested on their ability to communicate the findings from experimental activities using appropriate technical language, relevant calculations and graphs, assess the reliability of an experimental activity, and evaluate data and methods taking into account the factors that affect accuracy and validity. Okay, right, before I move on to the next bit, which is all about support, I can see that there's quite a lot of things coming to chat, so I will go back and have a look. Right, what is the difference between P1 and P2 questions? Well, that depends on whether you're talking about linear or modular. If you're talking about the linear, P1, the questions will only be set on that section of the specification that does not contain statements in bold type with the C prefix. In P2, questions can be set on every specification statement that's in the specification, including those with a that are in bold type and a C prefix. With regard to modular, then you've got questions that are going to be set on the specific topics that are in paper 1 and paper 2, which I outlined at the beginning. Are both 1C and 2C questions all short questions? No, there will be a mixture of multiple choice, short answer questions, and extended answer questions, and there will be calculations. Scheme of work can also be downloaded right along with the specification. Yes, it can be downloaded. Yep, for both modular and linear. It would be great if you let us know the difference between P1 and P2, because both contain the same content. So what's the difference? I think I've just outlined the difference. It depends on whether it's linear or modular. Okay. I'll say it again. If it's linear, P1, the questions will only be set on those topics that are not in bold and do not have a C prefix. In P2, in linear, questions will be set on everything, every single specification. In modular, you need to look at the specific topics for P1 and the specific topics for P2, and that's what will be assessed. Okay, moving down. Kindly, can you repeat? I think I've just repeated that for linear. Address the problems as teachers kindly respond us. Okay, I hope I've addressed all those problems. Okay. Okay, now what I'm going to do just for a moment is I'm just going to take a little, oh, there's another chat come up. Thank you, Cliff. So nice of you. That's what I'm here for. It's my pleasure. Okay, right. I'm just going to take a little break for, let's just say 4 minutes. The time here in the UK is 11 minutes past 10. I'm going to restart at 15 minutes past 10. So that's 4 minutes time. Okay, just give us a little chance to have a little comfort break should we need it. Okay. Don't worry, there still will be plenty of time for me to get through everything. So I'm just going to mute my microphone. UK time, I'll start up again. It's 10:15 now UK time, so I'll move on and cover the final section of support. I've just been asked about lesson plans. I haven't got any format lesson plans that I can actually show you, but I do believe that in the teaching hubs, there are some examples of lesson plans. So you might find that resource useful. Okay, here's the support for you at every single stage of the qualifications. Some of the ticks, unfortunately, have got out of the boxes. I don't know quite how that happened, but at the all of these are free resources. So at the teaching and planning stages, you've got the getting starting guide, you've got training events face-to-face like today's, online like today's, but also face-to-face. There are a lot of face-to-face training events now taking place. Hopefully, if the war in the Middle East doesn't escalate, I will be coming out to Egypt and Jordan in the second week in October. I think it's the 11th and 12th, I'll be giving face-to-face training events in Egypt, and the 14th and 15th, I'll be giving training events in Amman in Jordan, Cairo in Egypt. So if you happen to be in either of those two countries, then you may, and haven't already signed up for those particular training events, you may want to consider doing so. Hopefully they will take place. As I said, if the war escalates, then they may be called off. I'm keeping my fingers crossed that won't happen. There are some face-to-face, some online recordings also available on YouTube, in the Pearson section of YouTube, and there are also some on the website which you can listen to. They've been recorded and you can play them back. There's subject advisor support, and I will be giving you the details of the subject advisor for International GCSE Chemistry right at the end of the presentation. There are community forums that you can join. There's schemes of work available, there's skills mapping, there's sample assessment materials, and there are examiners' reports available for you. Okay. And there was also, okay, so for exam preparation, you've got, in addition to this, you've got obviously the sample assessment materials, the examiner's reports, you've got the exemplar mark resources all available on the website. You've got Exam Wizard, mark schemes, results plus, and mock exam analysis results plus, and access to scripts. And I'll be talking a bit more about all of those, combination in today and also in module 2. So more details of those coming up. So that's basically the sort of support that is actually available to you. Okay, there's the teaching and learning materials section. If you go to Pearson qualifications, International GCSEs, click on C for chemistry, then click on linear, and then click on teaching and learning materials, you will get that particular page come up. And you can see that on the teaching and learning materials, if you look at that little section, course materials over there, okay, you've got specification and sample assessment materials. You've got exam materials, which are all the past exam papers that have been taken. You've got all the mark schemes for every single exam paper, and you've got the examiner's reports on every single one of those papers. Okay, and then you've got the teaching and learning materials section, which contains a lot of useful information, some of which I will be talking to you about. Okay. We are continually adding to this, so keep an eye on it at all times. There's the equivalent modular one, and you'll see at the moment you've got specification, sample and assessment materials, and teaching and learning materials. No exam materials because there are no past papers set yet. One thing that I do need to make clear is that a lot of the teaching and learning materials, can you see there are 33 of them in linear, and at the moment, only 5 in modular. A lot of those teaching and learning materials in the linear one are also applicable and useful for the modular one. So I would advise you, even if you're teaching modular or planning on teaching modular, to use the teaching and learning materials from the linear section as well as what's in the modular section. Let's have a look at some of the guides. These are present in the teaching and learning materials section of the linear specification. There is a Maths for Scientists guide, which I would very much encourage you to look at, because it outlines the content that the students will have covered in their maths lessons throughout Key Stage 3 and Key Stage 4. Key Stage 3 is the 2 years prior to GCSE years, and Key Stage 4 is the GCSE years. You can use this guide to help you understand how different areas are approached in maths, and therefore support your teaching of the mathematical content in science lessons. I think it's very useful to teach the maths in science the same way as the maths is taught in maths lessons, so as not to confuse the students. The content is split into distinct mathematical contents. Each chapter takes you through the terminology used in that area, as well as examples taken from Pearson maths textbooks to show you the methods the student should be familiar with when solving mathematical problems. So I very much encourage you to read that guide. Okay, as I said, it outlines the content the students will have covered in their maths lessons throughout Key Stage 4. So that's, remember, in the teaching and learning materials section in the linear specification. In the same area, there's a topic guide which I wrote specifically for this specification on chemical bonding. Research has shown that students commonly acquire misconceptions about chemical bonding. Some of these can be persistent and may present significant barriers to students' progression and understanding of more complex ideas in chemistry. Many students studying at GCSE level, and also some studying at both A level and beyond, appear to develop a firm belief that species with full outer shells or outer shell octet configurations are more energetically stable than species with other electronic configurations. This is far from the truth. It's absolute nonsense. The electronic configuration of 2,8 for an atom of neon is not more stable or less stable than the electronic configuration of 281 for a sodium atom. If that electronic configuration of 281 were unstable, then it would change spontaneously, and it doesn't. It's stable, it maintains. It will only change if you put it into a situation that encourages it to change, i.e. encourages the sodium atom to lose an electron. And that, of course, will only happen if the energetics of the reaction are favourable. 281 is a stable electronic configuration for sodium. One study showed that over 97% of 15 to 16-year-olds tested believed that a sodium ion was more stable than the sodium atom. And that, of course, is not true, because to convert a sodium atom into a sodium ion, you have to give it energy. So it's the energy level of the sodium ion is above that of the sodium atom, i.e. it is less stable. Okay, the sodium ion is only stable in a particular environment, i.e. when you make an ionic compound, then the sodium ion becomes stable. It's not a stable entity as a single particle. More worryingly, about 80% of these students thought that an Na7- ion would also be more stable than a sodium atom. Since energy must be supplied to a sodium atom to either remove an electron or to add 7 electrons, the 2 ions are obviously at a higher energy level and therefore less stable. It would appear that the octet of electrons dominates the thinking of many students. This guide adopts a teaching approach to chemical bonding that does not involve the use of the so-called octet rule. Okay, so chemical bonding and related ideas, as I said, is acknowledged to be tricky. It's interesting that in 2016, so gosh, that's 8 years ago now, I was invited by the Institute of Education in Malta to go out and give 2 presentations to their teachers. They have A-level colleges where the students teach, the teachers just teach A-level. So they have A-level teachers and they have GCSE teachers in separate establishments. And my brief was to talk to them about myths and misconceptions in teaching chemistry at both levels. On the first day, I was asked to talk to the A-level teachers. And before I started my presentation, one of the teachers said to me, when you talk to the GCSE teachers tomorrow, could you ask them for a favour, please? And I said, I will ask if it's in my power to do so. And he said, will you ask them, please, not to teach the octet rule? It causes us immense problems at A-level when we've got to try and convince them that BF3 is a stable molecule, and even more worryingly, PCl5 and SF6. The students just don't understand why they can possibly exist because they are engrossed in this belief that the only stable arrangements are when you've got 8 electrons in the outer shell. So, and I said, it is on my brief. So they were happy. Okay, 2 others. I've just noticed that a few questions have cropped up. Okay, can you write, please, can you show us, can you write the links, please? Go to the this web page. Would you like to share the link of practical videos, topical resources? I say once again, Royal Society of Chemistry. Just simply go into your search engine and type in Royal Society of Chemistry, and that you will get a whole search come up, and you click on the link to the Royal Society of Chemistry and go into that particular thing rather than me produce a website. Okay. The teaching and learning materials, again, and as for the guides, again, I say again, okay, rather than share a link, type into your search engine Pearson qualifications, search, click on the link that says Pearson qualifications. Then you'll get a whole page come up where you can choose the qualification in which you're interested. And this time, of course, it's International GCSEs. Click on International GCSEs, and then you'll get a whole alphabet coming up, A, B, C, D, E. Click on C for chemistry, and then you'll see chemistry come up. Click on chemistry, and then you've got the option to go to linear or modular. Choose the one of your choice, okay? One or more questions. Why scheme of work have few contents in bold letters? Why? Because the ones in bold letters are those sections that are in the specification that are in bold and have got C prefixes. In the linear specification, they are the ones that will be tested only on paper 2. So that's why they are in bold. Okay? Because they're in bold in the specification. They can only be tested on paper 2 in the linear specification. I hope that answers your question. Okay, right, so let's move on. There are a couple of other things that I'd like to mention, and there's another topic guide on chemical equilibrium, which I wrote specifically to help support the teaching of this topic in the specification. So it's me, okay. It's interesting that in 1984, R.T. Aslop and N.H. George wrote an article published in Education and Chemistry. That's a publication from the Royal Society of Chemistry entitled Le Chatelier, a Redundant Principle, in which they argued that the use of the principle was counterproductive to the understanding of chemical equilibrium. Oh, sorry, excuse me. When I read this article back in 1984, I went to my head of chemistry and said, asked him if he'd also read it, and he said he had. And I said, they've got a very good argument, haven't they, that we really ought not to be teaching Le Chatelier's principle. And he said, yeah, excellent argument. Yeah, we shouldn't be teaching it. And I said, well, why are we? And he said, well, because it's on the specification. And unfortunately, on the specification that we were teaching at the time, it was on, and therefore we had to teach it. We had no option. But as I've mentioned already, Le Chatelier's principle is not on the International GCSE specification. It's also not on the International A-level specification, for very good reasons, that it is counterproductive, in my mind, to the understanding of chemical equilibrium. One problem associated with Le Chatelier's principle is it fails to predict the outcome of changes to conditions in a number of cases, particularly reactions involving gases where a change in temperature would lead to a change in pressure of a closed system. This guide points out the limitations of using Le Chatelier's principle to predict the effect of external changes made to a system that is not in dynamic equilibrium, and it offers an alternative approach that does not lead to misconceptions that can occur with its use. Okay, so although Le Chatelier's principle is not required for teaching International GCSE specification, a number of students refer to it in answers. And I've already mentioned that any reference that students make to it will be totally and utterly ignored. Okay, all I will say is please read the guide and make up your own mind as to whether you think that my approach will be suitable for your students. And if you think it is, I'll be very happy for you to adopt it. But it's up to you and your students to make that decision, okay? It's not up to me to make the decision for you. There's also the core practical guide. Now, I've had a lot of questions asked about the practicals. Every single question that you've asked will be answered in this guide. So I very, very much encourage you to read the core practical guide. It is covering all three sciences. So if you teach just chemistry, you focus on the chemistry section. If you teach more than one subject, then obviously it will be used to you for the others as well. But it gives an introduction to every practical activity that is listed in the specification, i.e. those ones that are in italics. It gives a description of that practical with some useful hints and tips. It's also got some questions to use with students to test their understanding as they do the experiment in the laboratory. And where appropriate, it's got a past paper question to use as a homework activity or classroom activity as you so wish. So there are four guides that I think are very, very useful for you to have a good read of. Okay, now I mentioned right at the beginning of the support Results Plus. And Results Plus is a tool that teachers may find useful in analysis of their students and their own your own teaching performance. Using Results Plus, you can see in-depth data on the performance of a candidate or a class or a school in reference to a particular cohort of examinees. Teachers can use this to see which questions and specification points students have performed well on and have performed poorly in, and use this in their choices around revision, resits, and future classroom teaching. If you go into the training section of the Pearson website and look at the training that I will be doing in Egypt and Jordan, you will see that the title is Enhancing Teaching for Exam Insight. And it is part of this is using Results Plus in such a way as to look at how your students have performed and then devising techniques and using other resources to possibly improve the way in which you develop the understanding of a particular topic. So if you happen to be in Egypt and Jordan, it's possibly not too late to sign up for those particular courses if they do go ahead and run. Okay, so a little bit more about Results Plus. It's free for all teachers of centres at schools that are signed up for Pearson Edexcel examinations. It provides a detailed breakdown of the student performance in the Pearson Edexcel exams. It identifies topics and questions where the student could benefit from further learning and informed teaching strategy and approaches. This will be particularly useful for modular, of course, because if a student has underperformed in a particular module, it may be that there's certain areas in that module where they've underperformed, and you could identify what they are and help them develop their understanding of those particular topics if they are then contemplating taking a resit. It does actually also benchmark your school's performance against other edX schools in your country, so you can see how well you're doing compared to other schools. It's not just a post-results tool. Mock exam results can also be fed into the system to produce analysis. You can find student results analysis from their previous Edexcel school, if they happen to have attended an Edexcel school, that is. And Results Plus Direct gives you your students access to their final grades and performance breakdown wherever they happen to be in the world. Okay. The best thing to do is to get access to Results Plus, which you have to do via your exams officer, because you will need a login and also a password in order to access it, and your exams officer can request that from Pearson's. Once you get in there, there is a guide on how to use Results Plus. So the best thing to do is to go into that guide and read it and develop your skills through using it. It's the best way of developing skills, okay? Please drop the recorded presentation in our email as a reference material. The event has been recorded and will be sent to you by Pearson's, not me. I think it's a great approach. Okay. Can you repeat where is support for exam preparation? Yes, teaching and learning materials on the Pearson website. Okay. Does that mean class assignments would have certain marks that will be included in the final examination, like the student performance in the class, that can also be counted? No. No. It just simply gives you an opportunity to see how your mock exam results compared with mock exam results for other schools. Okay. Okay. So again, the best way is, I don't have access to Results Plus because I'm not an existing teacher, so I can't. The only use of Results Plus is when you've actually got some results from your students. You need to get in there and use it when your students have actually sat exams, okay? So go into Results Plus and go through the guide. It's try learning it by doing it is the only way of learning how to use Results Plus. Okay, that's the link. That will be in the PDF version of the PowerPoint that is in the resource pack for you. Exam Wizard is another extremely useful tool. Okay. It's a free tool again that helps you make quick homework assignments, topic tests, and mock exams. Again, you need a login and a password, which your exams officer can get for you. And you simply type into your search engine, Pearson Exam Wizard. You'll get a whole series of searches come up. You click on the Exam Wizard one, that will take you into Exam Wizard, and then you simply will be asked to sign in, and you'll put in your login and your password, and you're in. And again, there is a guide as to how to use it within the Exam Wizard, but it enables you to be able to access all of the past papers that are set in UK GCSE exams, UK GCE A-level exams, international GCSE exams, and UK GCSE exams, both previous specification, qualification, and current qualification. So there's an enormous bank of past papers. And you can choose those past papers to download as an entire paper, but also the tool enables you to be able to select according to specific topics. It enables you to be able to select according to specific assessment objectives. So if you wanted to create a test on a assessment objective 1, for example, you could just simply click those questions, select those questions on AO1, or similarly AO2, or similarly AO3. You can click tests, or you can click on particular topics. So you can click on energetics and you get a topic, all the questions on energetics come up, etc. So it's an incredibly flexible tool, because questions are tagged against the unit, the topic, assessment objectives, so you can simply choose the whole past paper. Again, go into Exam Wizard and see what's available. The best way is to get in there and get practice using it through doing it yourself. Existing mark schemes are there for accurate marking. So you've got another way of getting the mark schemes other than getting them from the Pearson website. And also all the examiners' reports are there as well. The most recent exam content is available very quickly in Exam Wizard. And use the results to understand where students need more support and informed teaching strategies. In other words, enabling you to give formative assessment, finding out what they have done well and have not done well, and therefore helping you decide your own teaching strategies. Access to scripts is another very, very useful. Okay, again, it's a free online portal that allows teachers to immediately access electronically marked exam papers. Obviously, this is not available until the students have actually sat their exams and the results have been published. Once the results have been published, i.e. on the day the results have been published, you can access any student's exam paper that's in your particular school and see how that paper was marked. You obviously need the student's permission to do so because the paper belongs to them, it doesn't belong to you. So once you've asked the student, may I access your script, then you can go ahead and do so, okay? It's very useful because it offers complete, transparent approach to the marking process. You can see exactly how the script has been marked. It provides a better understanding of the marking before requests for inquiries about results are made. So if you've got a student coming to you and saying that he or she thought that they had done a lot better on a particular paper than their mark indicated, and therefore they're thinking about having an inquiry about result raised, which are very expensive, then you could go in, look at the script, see how it's marked, and then if you agree with the mark that's been awarded, you could go back to the student and say, well, I don't think it's worth having the inquiry about result because having a remark, because I think that it's been marked correctly. And that could save them a lot of money. If they then decide that they still want to go ahead and have it remarked, then okay, that's their decision. But at least you've given them an informed decision. If you look at it and you say, well, I can get 5 or 6 more marks out of this, I think it may be worthwhile having a remark, then at least then they've got an informed decision and they can go ahead and have that remark with the possibility that their mark may be improved. So again, it's very useful. It provides an excellent aid for teaching and preparing other cohorts for examinations by helping you to evaluate student performance on particular questions in relation to what they've been taught. So again, you can go back and look at this, and if you see a common theme running through your students of not dealing with a particular topic very well, then you can say to yourself, why haven't they dealt with that topic very well? I'm going to have to teach this topic to the next cohort of students. Is there anything I could do to improve my teaching? So you'll notice once again that I am very, very keen on evaluating. I always was on evaluating my teaching, trying to find out whether or not I had taught it well by getting feedback from my students, and therefore changing my teaching accordingly if I find that I wasn't getting the sort of outcome that I really was expecting. It's available instantly from results day for all of our exam series for a defined window. You can view and download scripts which have been marked online free of charge from our self-service portal. For more information on ATS and the results window, visit the results, post results pages on the Pearson website. Okay, there's a whole series of questions cropped up, so I'll see if I can go back and answer them. Okay. I can't post the PDF because I don't have your email addresses. So hopefully Pearson's will be able to sort that for you. Go to the results, it's available for download. Yes, thank you. It's there. You're welcome. Good. All right, someone's answered that question for me. Where can I find the recording this entrainment? It will be sent to you by Pearson's. Hello, for the recording, you can just go back to the lobby to access the recording once it's ready. Thank you. That's come from Claire, the moderator. Okay, so that's answered. Thank you, Claire. Good, that's answered. Okay, right. Everything's been answered. Okay, right. Well, we're pretty much towards the end of the thing. There are other resources available, but they are paid for resources. You've got the curriculum matched student books, okay, which give you some ideas of planning teaching, and you've got teaching hubs, okay, for exam preparation and assessment. All right, so you've got those additional paid for resources. The Pearson published resources you can get from that particular link, and that's the front copy. There are 2 other publishers that have produced books. Collins is one of them, and I'm trying to think of the other. I think the other's Hodder. If you haven't yet decided on a particular book, my suggestion would be to try and get an inspection copy of all three and see which of the ones you think is going to suit your students best. Very important for me to say, it is not a requirement that you use an Edexcel endorsed student book. You can use any student books you like. Okay, you don't have to use an Edexcel endorsed book. However, be aware that the reason why these books have been endorsed by Edexcel is because they've been checked to see that they cover all of the content in the specification. Other student books may not cover all of the specification statements in the specification. So you need to be aware of that. And if you use other student books, you will need to supplement, obviously, what is missing. Okay. And then you've got the teaching hubs. Okay. It is very, very pricey. I think it costs about £800, but if you've got the money in your budget, then it certainly is very, very, very worthwhile having, because it provides a fully comprehensive planning and front of class guidance. So when you talk to me about lesson plans, you've got a lot of comprehensive details on how to go about planning in that particular resource. You've got exam preparation resources, continuing professional support to help you deliver the International GCSE lessons to a very high standard, whether you happen to be a specialist or a non-specialist teacher. Okay, so that might be, okay. There's a lot of front of class resources linked from the lesson plans, including interactive exercises, animations, videos, plus an overview page containing all of the top level information about the lesson, as well as links to the textbook. So if you have the money in your budget, very, very worthwhile. Okay, very worthwhile buying. But I said it is quite pricey. It's been written by a team of expert subject authors with extensive experience of working on UK and international GCSE resources. These new online teaching hubs provide complete coverage of all guided teaching hours and can be used for live teaching as well as advanced preparation, saving you planning time so you can spend more valuable time teaching. So something for you to think about. Now, I did mention the subject advisor, and you will see that on the landing page when you click on International GCSE Chemistry, whether it's the linear or the modular. Tim Lawrence is your first port of call. So any questions about the qualification, about its examining, about its assessment that you're not sure of, simply email teachingscience@pearson.com and Tim or one of his colleagues will get back to you with an answer. Okay? All right. So, my last point, any further questions? There's one in the chat box at the moment. Are they free? Will we need PDF, please? Are you talking about the PDF of the slide presentation? Yes, it's free. It's in the resources in your delegate download. So just simply download it from the delegate downloads. Okay. You're more than welcome. Okay. Thank you for the thanks. I'll stay here to see just for a little while to see if there are any more questions. Big thanks. Thank you. Are the certificates for this training? Only Pearsons will know that. Claire, are the certificates sent out?
So, how can we get access to Result Plus?
Access to what? Results Plus. The way to get access to Results Plus is you have to go to your examinations officer and ask for a login and a password. Only the exams officer can request a login and a password from Pearson. You can't request that as an individual teacher. Exams officers or someone from the senior management team can do that. So they have to go. So you need to go to someone in senior management and ask them to get access for you. Okay,
Okay, thank you so much.
you're more than welcome. Okay, Claire, there, don't you? I think we can probably call it today there. Okay, and remember, please, all of you, that same time tomorrow, I will be going through the second module of this particular presentation of Getting Ready to Teach. So if you can make it then, I look forward very much to having the opportunity of talking with you again. Okay.